What? Someone is saying something. Roll number 11, not audible. What you're saying. Better you type in the chat box if you want to say something. Okay, let me share my screen. Is the screen is visible? Is the screen is visible? Type in the chat box. No, ma'am. Just wait for a minute. Okay, visible now, no? Right, okay. So today we'll study how many students? 20. Please, CR, if CR is in the group, please put a message that class will start soon. And as I'm discussing new topic, it will be difficult for me. Okay. Okay. So today we'll study forces and movements transmitted by slender member. Okay. So basic first you should know what is slender members. So we shall note that a large portion of the load carrying members can be classified as slender members. The members or structures which carry loads where is also classified as slender members, and by a slender member we mean that whose length is much greater than the either of its cross-sectional dimension. That means if you have a cylinder, then its length will be very long compared to its diameter. Okay, your let me show you. If this is your beam, so this I'm taking an example of beam. So if this is a beam, your length should be very greater than its thickness. Screen is not visible. What about others? Screen is not visible. Roll number 23 says screen is not visible. What about others? Please reply me soon so that I can continue. Visible, ma'am. Okay, thank you. So this is our beam. Please check your roll number. Please check your connection. So this is a beam, and this is the. See, if some students are able to see, then maybe it is visible. Please check your internet connections. Okay. Okay. Let me share once again. Let me share once again. Now it is visible. Please respond soon. Now it is visible. What about others? No one is able to see. Why it is happening? Actually, visible now. I've shared once again. Now it is visible. Hope this is visible. Okay. So basically, a slender member. By slender member, you mean that its length will be much longer than its cross-sectional area. So your length will be much bigger than the cross-sectional area. So these are the examples: beams, columns, shaft, rod, stringers, struts, and links. Okay, these are some examples of your slender member. Even if a long thin rod is formed into a hoop or a coil spring whose diameter is large compared with the thickness of the rod, it will retain its identity as a slender member. Okay. So general method of the analysis. So how to analyze these? There are some steps. Okay. At first is your idealization. Idealize the actual problem, create a model of the system, and isolate the main structure, showing all forces acting on the structure. So this idealization means draw the free body diagram. What are the loads acting on the members? So you have to idealization means you have to idealize what are the forces acting on that member. Then you have to use a continuity equation, summation of all the forces equal to zero, summation of all the moments equals to zero to find the external support. Same, this is kind of same method of joints and method of sections. First, you have to draw the free body diagram. Then you have to find out the external supports by using these equations. Then cut the member at a section of interest. Isolate one of the segments and repeat step 2 on that segment. That means you have to cut the section where you have need to find the forces and movements. Okay, in this chapter we'll study how to find its forces and movements and how to draw shear force diagram and bending moment diagram. We'll come to that later on. So basically the same step. First you have to draw the free body diagram, then you have to find the support reactions by using these equations. Then you have to isolate that part where you need to find the forces and moments and repeat the same step. That means you have to again use these equations to find the forces and moments. Okay, see, this is the beam is given. Okay, let's start with the basics. Are you able to see my new screen? Chapter. Are you able to see my new screen? Chapter. It is written here. Chapter 2: Shear force and bending moment. It is visible. Just wait a second. Wait a second. It will be. It will be. It is showing chapter 2: Shear force and bending moment. A PPT kind. Is it visible? Please respond. Is it visible now? Experiment 3.1 is showing no, ma'am. No, no, I have changed the screen. Let me share once again. Now it is visible. It is written chapter 2: Shear force and bending moment. Some diagrams are given. Chapter 2: Shear force and bending moment. '28. Visible? Shall I move? Some brown background where it is shown with blue color, dark blue color. Chapter 2: Shear force and bending moment diagram. Is it visible? It's stuck to the number of participant page. Okay, let me share once again. Maybe network issue. Let me share once again, okay? Now it is visible. Chapter 2: Shear force and bending moment. Visible? Please respond. Okay, then let's move. So see, what is the need of shear force and bending moment? Okay, we generally find shear force and bending moment. See the structure. Okay, these are the loads acting on the members. So if you take this as a beam, This is the column, right? This is the column, and these are the beams. These are actually, this is the floor. This will be the beam floor beam. Sorry. So these beams are connected to these columns. So from the shear force, whatever we get shear force, we design for shear reinforcement. Okay, to protect this, to protect shear force in a structure, we design for shear reinforcement, and to protect bending movement, we design flexure reinforcement. You will come to this part in junior sir class, shear reinforcement and flexure reinforcement. So first we'll discuss types of beams, then we'll discuss effects of loading on beams, then the force that causes shearing is known as shear force. Okay, and the force that results in bending is known as bending moment. And then we'll see how to draw shear force and bending moments diagram. So you have different types of beams. Member with support loadings applied perpendicular to their longitudinal axis are called as beams. So beam is a support loading applied perpendicular to their longitudinal axis. So this is your beam. This is also a slender member. Your length is more than its cross section. Okay. So this is a simply supported beam. The beam is supported, one pinch supported, one roller supported. Okay. One more important point: you cannot provide roller support on both the locations, because as you know, this cannot restrict your horizontal movement. So you cannot provide roller support in on both the sides. So this is a simply supported beam. Okay. Types of beams are classified according to the way they are supported. So based on their support, they have been classified. Number one is simply supported. One support will be roller, one support will be hinge. Next is overhanging. See, some part of the beam is overhanged. Okay, so this is overhanging beam. Then we have your cantilever beam. Cantilever means the beam is fixed at one position and the rest part is overhang. Okay, so cantilever portion, the part is, this is hanging. So this is, and one part is completely fixed. So this is a your cantilever beam. Okay, simply supported, cantilever, and overhanging beam. So these are the basic types of beam. And there will be one more beam which is also called as fixed beam. That means both the part will be fixed, both the ends will be fixed. So four types of beam: simply supported, cantilever, overhanging, and one will be fixed, both the ends will be fixed. So as we have discussed earlier, that roller support will have only one reaction, right? Only vertical reaction. When you have roller support, you will have only one reaction, vertical. But with pinch, you will have vertical plus horizontal. And in fixed beam, you will have three reactions: vertical, horizontal, and movement. That means this support will resist vertical movement, horizontal movement, and the rotational movement. Okay. Fixed beam can resist three reactions, or three movements: vertical, horizontal, and the rotation. And this roller support can only restrict your vertical, and this one vertical and horizontal. Hope this part is clear. We have seen four types of beams. Now the supports. As a general rule, if a support prevents translation of a body in a given direction, then a force is developed on the body in the opposite direction. Similarly, if rotation is prevented, a couple movement is exerted on the body. So this says that if a support prevents translational, that means if a support prevents your vertical and horizontal movement, then a force is developed, okay, on the support. And if resist your rotational movement, then there generates a movement. So we have types of beam as determinate beam and indeterminate beam. The force and moments of reaction at supports can be determined using three equilibrium equations. If this from these three equilibrium equation we can find the supports. Suppose if I see, this is my beam. I have a roller support here, okay, and I have a hinge support. So what? How many reactions I'll have? One, 2, and 3, right? So to find the support reaction, if I cannot use, if these three equations cannot give me these three value, then your beam will consider as indeterminate beam. But if you can find these three reactions from these three equations, then your beam will be considered as determinate beam. The force and moment of reaction of supports are more than the number of equilibrium equation of static. So this says indeterminate. So this is the basic difference between determinate beam and indeterminate beam. So this is the shear force and bending moment diagram. So in order to properly design a beam, okay, it is important to know the variation of the shear and moment along its axis in order to find the points where these values are maximum. Okay. So to describe this, let me get back to this will be fine. So it why we need shear force and bending moment diagram. Suppose this is your beam. Okay, variation of load is not equal. Suppose you are getting much load here, you are getting less load, you are getting different load, different load. So you should know. So to design how much reinforce. See, if you provide the same reinforce throughout the section, then your structure will not be economical. Okay. So based on the shear force, shear force you are getting on that structure, if you design the structure based on that range, suppose you are getting 410 shear force in a beam at some location, and another portion you are getting 800 kilonewton. So if you design, if you give reinforcement as per 800 kilonewton in the 410 part, then your structure will not be economical. Okay, you are giving more reinforcement, but it needs the reinforcement just to prevent 410 kilonewton, right? Getting my point? Why we need shear force? We need shear force to design the shear reinforcement, and bending moment to design flexure reinforcement to prevent the bending of the structure. Suppose this is my beam, it will bend due to loads, it will bend, right? And it will break. So to prevent this breaking, we provide reinforcement in the shear force and bending moment portions. So this is the variation of shear force shown by green part. Based on, depending upon the load, different shapes. Okay, and different shapes of movements. Okay. So principle of movement. The movement of a force indicates the tendency of a body to turn about an axis passing through a specific point O. And the principle of movement, which is sometimes referred to as Vignon's theorem, states that the moment of a force about a point is equal to the sum of the moments of the force components about that point. So I have discussed this one, that your moments will be, suppose moment about m, you need to find the moment about n. So this summation of moments will be moment due to this point, moment due to this point, moment due to this point. We have done this part, right? So this theorem says the moment of a force about a point, that means about a point m, is equal to the sum of the moments of the forces components about that point. And moment has a formula of force into distance. If a support prevents translation of a body, translation means your vertical and horizontal movement in a particular direction, then the support exerts a force on the body in that direction. We use the beam's reaction by these equations. So let's start with an example. The beam shown below is supported by a pin at A and roller at B. Calculate the reactions. Let's start with reaction. First we'll find the reaction, then we'll move to shear force and bending moment. So calculate the reaction at both supports due to the loading. Can you find the support reactions based, we have done in method of joints, right? Can you find the support reactions of this beam? Please respond in the chat box. Can you find the support reactions in this beam? Yes, find out. Find out and tell me. Just try and tell me. It will take your 2 minutes. Got it? Response. Yeah, are you able to find it or not? Next, Ax equals to 0, okay? And what about others? Others 29 students. See, why I'm taking live class? This is interaction class. Find out. If you're not able to find out, then write didn't understand. I'm asking you to find the support reactions. At roller, there will be one reaction. Consider this one as at roller there will be one reaction considered as VB or BX, whatever what you want. There will be two V X. This will be suppose you are taking VY, VAY. Suppose you are taking this one as good AY, VAX, and this one VBY. So I am asking you to find these three values VBY, VAX, and VA. Let me remove this part. I'm asking to find VAX VAX and V. Okay. And what about others? You don't respond also. Okay. So see, first, okay, that okay, good. 24 and 1, good. So see, this is the beam, roller support, in support, and we have two load 20 and 40 kilonewton. Okay. So we have to draw free body diagram. We have drawn the free body diagram. Roller supported is replaced by one reactions RBY, and pin supported is removed by two reactions. Okay, this is general. This one is RAY and this one is RAX. Okay, so these are the support 20 kilonewton, 40 kilonewton, and 20, these are at distance of 2 meter, 3 meter, and 4 meter. So what we'll do, we'll first I'm taking by taking the moment at B. I'm taking the moment at B. So what will be the first reaction? RAY into I know moment is nothing but force into distance, right? And I need moment about B point. So Ray into this will be the force and this will be the reactions 2, 3 and 4. So Ra into 9 minus, see I am taking this one as positive, so I will take downward as negative. So Ray into 9 minus this 20 into how much is the distance? 7. 7. Again this is in downward direction, so minus 40 into what is the distance? 4 meter equals to 0. So summation of all the moments about B point I am taking as 0. So this is the equation I got. Mom Summation of all the moments. So force into distance, force into distance, this force into distance. So I got Ray as 33.3 kilonewton. Rule number 24 and 1 was correct. So I have used this equation. Now I can use summation of all the vertical forces equals to 0. See, horizontal force will be 0 because there is no another horizontal force. Right? So Rx equals to 0. Summation of Fx equals to 0. So Rx equals to 0. So I have used two equations. Next I left with summation of Fy equals to 0. That means summation of all the vertical forces equals to 0. So I have Ray plus Rby minus, these are in downward direction, so minus 20 minus 40 equals to 0. And I have found out Ray value as 33.3. So I can take that value and I can find Rby. So this is how you have to find the support reactions in a beam. This is the second step. First step is you to draw the free body diagram, then you have to find the support reactions. Okay. Hope understood. Now, can you find this one? So, okay. I have not discussed one thing, that what will the types of loads. Okay, you should know various types of loads. Let me see. Let me see if it is. Yes. Let me see. Just give me a minute. Okay, it is not here. So let me show you. Okay, so there will be different types of load. Basically, there will be different. Suppose this is a simple beam, and these are the loads. So these are the uniaxial loads. Uniaxial loads. These are the simple loads. Okay. Suppose if you are getting these are the unit of this load will be in kilonewton only. Okay. If I give you load like this, forget about this 20. Okay, forget about this 20. If I give you load this, just forget about this 20. Okay, if I give you load along the section of the beam, so this load will be considered as UDL. That means uniformly distributed load. UDL, uniformly distributed. Suppose 50 kilonewton per meter. Okay, so how much is the meter? 9 meters. So 50 kilonewton along the 9 meter. Uniform UDL. This is the line load or point load. This 20 and 40 are considered as line load or point load also. Okay, so this 20 and 40 kilonewtons are point load, and if the load is represented along the whole length of the beam in equal amount, so this will be uniformly distributed load. Understood? What is point load? Point load will be only this one. This load means this load is acting at only at this point. Okay, and this one is uniformly distributed load. The load is equally distributed along the length. It is also known as UDL. Short form is UDL, and you can say that as uniformly distributed. See, the load is uniformly distributed over the length. Okay, and this unit is kilonewton per meter. Then I'll have uniformly varying load. That means suppose here you have highest load and here you have the lowest load. So this will be considered as uniformly varying load. Understood? This will be considered as uniformly varying load. That means at one point it will be very high and at one point it will be zero, and this at every different point it will be different load. So that it is also called as UVL, uniformly varying load. At one point it can be high, maximum, and at one point it will be zero, and at different point it will be different load. Understood? So we have discussed point load, uniformly distributed load UDL, and UVL. Point load, UDL, and UVL. Point load means this simply this 20 and 40 kilonewton are considered as point load. UDL, if I give UDL, so the whole beam will be considered. The whole beam will experience same uniform load, or and UVL will have varying load. So in the next question, see, uniformly distributed. That means this beam from this portion to this portion, the load is same. That means 15 kilonewton per meter. Okay. And this is the overhanging beam. Support reaction is given. You need to find the support. So see, just absorb this one. I'll not just absorb this one. If you find any difficulty, then write in the chat box, then I'll discuss. I'll discuss by myself also. Where you find the difficulty in understanding this slide, just let me know. I'm not saying anything. Actually, I have given you a task that go through this and understand. Have you understood how you have how you need to find this and this value? I have given you a task. Just go through this slide once. See, okay. So hope you have understood the free body diagram. Okay. I have replaced the roller supported by this vertical force. I have replaced the hinge support by this vertical and horizontal force. Okay. Now for this UDL, how to find the load? Suppose for movement you have force into distance, right? Just concentrate, just give interest, okay? Otherwise we'll do mistakes. So for UDL, that means for this 15 kilonewton per meter, if you need to find movement, how will you find the movement? So it will be like this: 15 into at this is 15 per meter. Okay, that means for 1 meter it is acting 15 load. So and how much distance is given? 3 meter, right? So 15 into 3. This is the force. Okay, you have found out the force how much? 15 into 3. Why 3? Because it is saying 15 kilonewton per meter and you have been given 3 meters. So 15 into 3 will be your force into your distance will be always the half. Whatever the distance given, you have to take the half. That means 1.5. Understood? Have you understood? You have to take the half of this distance to find the moment. Okay. So see here in this okay. Let me allow some students. They are in the waiting list. Okay. Let me unlock the meeting first. Go through this one. Understand? Okay. So I'm taking by taking the moment at A. So I'm taking all the moments about A point. Okay. So what will be the first force? I can take 20. I can start with 20. Okay. Let's start with this. See, this RB into this distance. 3 in plus 4, 7. And why I have taken minus? Because I'm going anti-clockwise. Sorry. Yeah. I'm going anti-clockwise. I have considered, see, if I take from force this direction, this will be clockwise, right? So I've taken clockwise as positive, so this one will be anti-clockwise. Force into distance, so this will go like this. So that's why minus RBY into 7 plus this plus 20 into, now in this equation I have taken this one as downward direction as positive. It's up to you. You can just remember, if you are taking upward as positive, you always take upward as positive in a problem. Suppose in earlier problem we have taken upward as positive, downward as negative. But in the next question I can take, but throughout the solution part you have to take the same sign. So this person has taken this downward direction as negative, sorry, positive. So 20 into, how much is the distance? 7, 9, 9 minus again this one. Okay, so 15 into, I have discussed just recently, 15 into 3, that is the force part, and the distance is 4 plus 1.5. So how much it will be? It will be 5.5 equals to 0. Solve this, you will get RBY value. Now this part is over. Now summation of Fy. So all the vertical forces should be 0. Okay, there is a mistake. This sign should be in minus. This sign should be minus. Is the support below 20 kilonewton fixed, ma'am? No, there is no support. This is the overhanging part. There is no support. See, the beam is overhanged. Let me show the earlier picture. Beam is overhanged. There is no support at 20 kilonewton. Okay. Over the 20 kilonewton is acting on the overhanging part. So see, make a correction. This one will be negative. Because see, they have taken here all the downward direction as negative. No. I am taking this one as anti-clockwise, clockwise, and this moment will be clockwise. Okay, correct. This one will be positive because it will give you. See, this 20 will give you clockwise movement, right? Ma'am, how it is 5.5 came? I have discussed now how it is come 5.5 for UDL. Let me explain you once again. For UDL always take half distance, L by 2. Okay, for the UDL part only. For the UDL part always take L by 2 because you are taking the distance in the load itself. Okay, so this 4 plus 3 by 2 is how much? 1.5. And 4 plus 1.5 will be your 5.5. Let me explain once again. For UDL conditions, to find the moment, you have to use force into distance, right? So for UDL, you will have force. How much is the force? 50 kilonewton per meter. Earlier used to take only the load, which is 50 kilonewton or 40 kilonewton. But here it is given 50 kilonewton per meter. That means 15. This means 15 kilonewton is acting per 1 meter. But the distance here given is 3 meter. That means your 15 kilonewton is acting on all the 3 kilonewton. So it will be 3. So this is your force. Now the distance. Now the distance will, you are finding moment about B, right? So distance of this UDL. So see, you cannot take 4 plus 3, 7. You cannot take 4 plus 3, 7 because this UDL is acting at 4 also, right? This UDL is acting at 4 also and at middle also, and it is taking at 7 also. That's why what we do, we take a half of this. So it will be, the distance will be your 4 plus 3, it will be 5.5. Have you understood this one? See, Generally, if the load 20 kilo, simply 20 kilonewton is applied at this point, so I could have taken the 7. And if this load is acting at this point, I could have taken the simply 4. But this load is acting over the whole 3 meter span. So I cannot take a particular value. So the easy way to take the half of this. That's why 4 plus this half of this will be 1.5 and 5.5. So this is the value. And this plus is okay because it is giving the movement, so it will come like this now. So the same is just taking upward direction as positive, downward direction as negative. So this part is clear. Next come to summation of all the vertical forces as 0. So vertical forces is this one minus 20 minus 45. How 45? See, load is how much? 15 into 3. That's why 45. This load, you have to take the load as 15 into 3. Suppose here it was given as 6 meters. So you have to take load 15 into 6. Got it? So I have got this value. Now there is no horizontal force, so that's why Rax equals to 0. Have you understood this one? Or should I explain once more? Response. Should I explain this one once more, or you have understood? Once again. Okay.
Clear, ma'am.
Clear.
Ma'am,
Yeah.
ma'am, if the beam is extended to the right of A and then there is one load acting downward, so like what will be the sign convention?
That means you are saying ki, instead of extending in B part, if it is extending in 8 part, right?
Ma'am,
It will be same. There
yes,
will
ma'am.
be, suppose that means you are saying the beam will be like this. Uh, support at so this is the hinge support, this is the roller support, and you are saying 15 kilonewton is acting at this point. So is there any 20 kilonewton load here? Please response.
Ma'am.
You are saying 20 kilonewton load.
Yes, ma'am.
Is there any load here?
Yes, ma'am.
Same 20 kilonewton, right? So you have to find the same way. You have to take the moment about this sign convention. See, sign convention means this load will go your anti-clockwise. So this will be minus 20 into the distance about which you need to find the moment. This one is, see, this force is acting and distance is acting this one. So this will come like this. If you are giving overhanging in this part, so this will give movement in this direction, and we are taking anti-clockwise as negative, so it will be negative. Clear?
Yes, ma'am.
Okay. Abrisha, okay, let me explain once again quickly. I'll be lagging behind like this. Okay. Okay, let me explain once again. So see, Abrisha, just see, this is the beam is given to us. Okay. The hinge support, roller support, and UDL and point load. This is your UDL, uniformly distributed load. From 3 meter, it is the load is uniformly distributed, and this one is point load. So I have drawn the free body diagram, right? Now I have shown the support reactions. Now I have to find the RAX, RAY, and RBY. RAX will be, okay, guys. This meeting will end in 5 minutes. So write your roll numbers in the chat box, please. Write your roll number in the chat box. I don't want to lose the attendance. So Abrisha, see. So I have to find the support reactions. RAX will be completely 0 because we don't have any horizontal force acting on this beam. This part is over. Okay. Next come to the movement part. So I am taking all the movement at A. I am taking the movement at A point. And you know, to find the movement, you need to you have a formula, force into distance, right? So this one will be one force, RBY. This force into this. I'm taking, so this one is giving us anti-clockwise movement. I'm taking anti-clockwise movement as negative and clockwise movement as positive. So RBY is giving me anti-clockwise movement. So I'm taking minus RBY into this distance. And this 20 will give me clockwise movement. That's why I'm taking positive 20 into the distance will be 4, 3 and 2, 9 meters. Done. Then this 15 meter, see this is the downward direction. Again this will give me clockwise direction. Sorry. It will give me a movement in the anti-clockwise direction, right? So minus, for UDL you have, you need to find a moment force into distance. So for UDL your force will be 15 into 3. Why? See, this is 15 kilonewton per meter and you have 3 meter. So see, and just see the basics. Force has a unit of Newton, right? So how can you write 15 kilonewton per meter? So you have to multiply by meter. If you multiply 50 kilonewton per meter, if you multiply by meter, the distance it is acting apply 3 meter. So this meter will cancel out and you will get 15 into 3, 45 kilonewton. So this is your force. Into the distance is your, this 4, you need to find the moment about A point, right? So 4 is already a distance. Next distance will be always with the half of the distance it is applying. It is acted on. Okay. So you have to take the half of the distance. Why half? See, this load is not acting exactly at 4. This load is not exactly acting at 7. I cannot take 7. I cannot take 4. I have to take intermediate distance, right? Because it is acting uniformly. So what is the best option? Take the half of the distance. So I'm taking, that's why 4 plus half of 3 is 1.5. So 4 plus half is 5.5. So this is how we have founded the RBY. Then summation of all the vertical forces you will get. This 45 is nothing but this one. Force is 15 into 3. Okay, that's how. Okay, see you in the next class. Okay, I will continue from